Hi there, welcome to Nauctis on YouTube.
Have you ever wondered how the internet can reach the far corners of the world? Behind the incredible internet speed we enjoy today, there is an extensive and intricate network of undersea cables. These cables connect continents and islands around the world to produce quality internet and enables people to communicate globally with ease. While overhead cables are land-based and limited to certain areas, underwater cables have a much greater reach, both technically and physically. Moreover, subsea cables have the advantage of being less vulnerable to natural disturbances such as rain, ice, snow, storms, or natural disasters like tornadoes or forest fires. This is all thanks to the cable-laying ships that have been instrumental in installing cables underwater. Cable-laying or cable installation ships are a type of deep-sea vessel designed and used to lay subsea cables for telecommunications, electric power transmission, military, and other purposes. Cable ships first operated around 1857 and 1858 to install transatlantic telegraph cables. These cables briefly enabled telecommunications between Europe and North America before their misuse led to channel failure. In 1866, the SS Great Eastern successfully laid 2 transatlantic cables securing future communication between continents. Unlike their predecessors, modern cable-laying ships come in 2 types: cable repair ships and cable-laying ships. Cable repair ships such as Japan's Tsugaru Maru tend to be smaller and more maneuverable. These ships can not only lay cables but also repair damaged cable sections. On the other hand, cable-laying ships like long lines are designed to install new cables. Cable-laying ships are larger than repair ships and less maneuverable. Their cable storage drums are also larger and installed in parallel, allowing one drum to be inserted into another. This enables faster cable installation. The cables laid on the seafloor come in 3 types: telecommunication cables, power cables, and military cables. Telecommunication cables are used to carry voice, data, and video traffic between continents. Power cables are used to transmit electricity between power plants and distribution centers, which in turn provide electricity to our homes and businesses. Military cables are used to communicate with and control military assets. They are essential for our country's defense and security. However, there is also a newer design of cable-laying ships which combines cable installation and ship repair. An example is the USNS Zeus, the only cable-layer repair ship owned by the United States Navy. This ship can lay telecommunications cables up to approximately 994 miles long and at a depth of 8,858 feet. The Zeus is also built to maneuver as much as possible, allowing it to fulfill both roles as a repair ship and a cable-laying ship. The equipment commonly used on cable-laying ships usually depends on the job requirements. To retrieve damaged or broken cables, these ships typically use a grapple system. The grapple is attached to the ship via a grapple rope, which initially was a mix of steel and manila rope but is now made of synthetic materials. This ensures that the rope is strong and can flex and stretch due to the grapple load. Additionally, 2 features make cable-laying ships easily recognizable: the stern sheaves and the carousel or large tank that holds the cable. The stern sheaves are designed to facilitate cable laying, which was previously done from the back. However, on modern ships, it is usually done from the stern or rear. Meanwhile, the carousel is located near the middle of the ship. Large ships may have several carousels, each capable of holding thousands of tons, or a total cable length of 1,864 miles. Once the cable is loaded into the carousel and the ship has begun the installation process, the cable is fed from the large basket into the plow. The plow is a device that digs into the seabed and creates a trench where the cable will be buried. The plow is suspended below the ship and can use high-pressure water jets to bury the cable up to 3 feet below the seafloor to prevent fishing vessels from snagging the cable as a hold-fast for their nets. This plow can be used for transatlantic cables, inter-array wind farm cable installation, and export cable burial. One well-known plow is the Sea Stallion plow, designed by Royal IHC, which has been in operation for over 20 years to bury cables. Before plowing a trench to bury the cable, the crew will determine a very specific route to avoid coral reefs, underwater rocks, and areas commonly used for ship anchorage or fishing. Because cable laying is a job that requires high precision in an unsuitable environment, cable laying ships have a dynamic positioning system. This system uses computer control to keep the ship in its intended location, even in high waves and adverse weather. The positioning system is also necessary for repair work, as the ship will likely need to stay in one place while a remotely operated vehicle or ROV or a diver is underwater performing cable installation. Dynamic positioning systems are rated as DP1, DP2, and DP3 for different levels of redundancy. DP1 ships are the most basic level, while DP2 has additional redundancy built into computers, systems, power, and more. DP3 has the most robust system. Cable-carrying ships typically fall into the DP2 category, although some are classified as DP3. The DP3 category is required whenever divers are involved, so cable repair ships need a Level 3 redundant system for safety. DP system failure can damage equipment, sever cables, or leave divers underwater. Cable-laying ships are also generally equipped with a linear cable engine or LCE, which can help them install cables in a short time. The LCE is used to feed the cable to the seafloor, but this device can also be reversed and used to bring up spare cables that require repair. The machine can lower cables at a rate of 787 feet per minute. When laying cables, the ship's speed is limited to 9 miles per hour. This is done to ensure that the cable lies correctly on the seabed and to compensate for any minor adjustments that may affect the cable's position. The LCE is also equipped with a braking system that allows the cable flow to be controlled or stopped if problems arise. This system is commonly used for fleeting drums, mechanical drums equipped with EO-duals that help slow down and guide the cable into the LCE. As time passes, cable laying technology continues to evolve, and more cables are being installed to transmit increasing amounts of data. For example, one of the most advanced cable-laying ships today is the Leonardo da Vinci, which has a maximum speed of over 16 miles per hour. The Leonardo da Vinci has a total payload of 37,479 tons for 2 carousels, giving it the highest capacity of any cable-laying ship in the world. The ship is also equipped with a DP3 system and can operate autonomously for 90 days, supported by a hybrid system, and can carry 2 underwater ROVs. Cable-laying ships are specifically designed to fulfill the purpose of installing cable routes underwater. However, since cable installation work is not done all the time and throughout the year, cable-laying ships are often used as research vessels to monitor various events in ocean and sea waters.